how to use lean design and construction to form a collaborative approach on your next project. And when I think of BIM, and not just the modeling, but the information, and when we started this conversation of the next person down the line, it gives you an idea of this kind of an assembly line of information. And many times when I'm thinking about construction, it's information and communicating that, and how do you take something that's a three-dimensional object in a designer's mind. For many years we put it back down on a two-dimensional medium, tried to reinterpret that from the contractor's point of view and create a three-dimensional object. And now this flow becomes much more interactive, and that's really going to be the point of what I'm talking today, is that it's we're talking about a massive database, and we all use the same information in a lot of different ways, and hopefully you'll see how we're able to do that. The part that I like about this also is it's really BIM seems to change the way we look at things and made construction much more customer focused. We're able to ask better questions and give them a better product. For us, a lot of the stuff is Peter Drucker's at the core of what we're doing, and it gives us an opportunity to really ask what's important, because we're able to communicate that mind's eye with the model sooner, and it cuts down on changes later on, and it also allows us to be a lot more agile. And then we also see this as giving us an opportunity to be a lot more innovative. With many of our clients, especially, they're becoming much more sophisticated in things like augmented reality. That's what they view the world, and what they see in the model is what they expect to be built, and we're able to we see it as very exciting. We can do these models, but one of the things that we have to inform the design, and a lot of what we're talking about with modeling, in the construction, has come from modeling in aircraft industries and things like that. But basically, we're creating a space, and we find that starting with the mock-up, giving that opportunity to have that owner get out and feel and inform the model, makes the model a lot more robust, because we're going to, as I'm going to show you, we're going to build to that model. So these are just pictures of us on a project mocking this up, and having the owner be able to touch and feel and position what they're going to be seeing later on. The other part of this, and we are going to talk about modeling, but it allows us, in the part of the lean part of this, is time and motion studies, and this is just an example of a mock-up of an OR, and that again is monitoring, is getting perfect information in the model to transmit that information back into the design. So as you do these models, again, with this industrial engineering and the part that modeling allows us to do, we start to realize that basically we all move at 240 feet per minute. And this allows us to look at industrial engineering and applying it to our models, and what designers are doing to make sure that the space is even more efficient as the people are moving throughout the building. That also fits in with our construction. Okay. This was developed, this is a great model that I developed with an architectural friend of mine several years ago. And when you look down in the lower right, we talk about installation, and we have this assembly line approach. And my friend Tim, when he started talking about the design process, you can see that the design narrows, but design is fluid, and it moves along in a lot of different directions, and you don't always know when you get the answer. And in a lot of cases, as designers, you hear from contractors that, hey, this is on critical path and I need this answer now. Unfortunately, answer 6 is the one that a designer may have, and answer 1 isn't there for quite a while. The one part with modeling and this collaborative approach allows us to, when we have answer 6, because in a lot of cases we can pull that piece off and model it, and it's much more mathematical. We don't have to have all the answer. We don't have to have answer 1 to get started. So it doesn't drive out construction. The part that really works out well for this with modeling, and I see it as in a collaborative approach, is when we do it like this, I don't have to say we're on critical path and our schedule is going off. I can pick and choose the pieces that we, as the information comes from design and the clients, we can start working at those. Once we have all those pieces, because of that precision, then we can do a lot more prefab, and that makes installation at the construction site a shorter amount of time. So this gives we like the term consign, where we took construction and design and kind of put them together. It fits in for kind of an integrated project delivery, and makes the builds, the design and build, a much more effective process. Kind of getting into the nuts and bolts. One of the interesting things about modeling is, it really ends up being a mathematical algorithm. We've got a mathematical database behind this, and what you're looking at here is a topographical survey of a 26,000 square foot set of operating suites. What you can see down on the lower part of here, we've got the standard ABC 1, 2, 3 grid lines, but we've also got ordinate dimensioning. And the coordinates, when you think about it, if we go all the way back to AutoCAD, when they used to have a handle and a unique identifier, when I really think of, there's an infinite number of points and no object, the truly unique identifier is that X, Y, and Z coordinate. As you start to think about that, of these parts and pieces and how they all fit in, with that, it starts to, if you're looking at it from a design standpoint of positive and negative space, we're able to locate exactly where parts and pieces start to go, and it gives us a lot more flexibility. The equipment, when we take it into the field, looks at those X, Y, and Z coordinates, and it makes it, that's how we're utilizing the data. The unique part about this topographical survey that you're looking at shows an existing concrete slab, and we had gotten design from the architect, the architectural firm, and we went through and systematically picked coordinates for doorways and medical equipment that had to be really precisely located, and went in and got specific elevations in basically less than 12 man-hours for where the existing slab was. What was nice about this was it fit into, we were able to get costing information up front, so it informed us as to where what the cost for elevating slabs were going to be, and it also, we raised the slab elevation in the Revit model to reflect what existing conditions were. So the usual, half-inch fluctuation that you have sometimes was not part of the equation. In the real world, we had real-world coordinates. This was important because we were putting in a biplane unit, and it had, from ceiling to floor elevation, there was either a 0 or a +3/16 tolerance, and we were able to hit that. So it makes it the most cost-effective way to do this work, and then it also increased the quality. We didn't have the standard issues with casework or doors. It's an extremely effective way to gather information and feedback into your model. This was the space when it was completed, and this is really what we see as the future. We call it built to design, kind of perfection at the connection. So when you think about it, as-builts are a measure of failure. It's either a failure of the construction team to match what the design was asking for, or failure of the design to match what could actually be built. So when we approached this particular project and increasing our ability from the last project, we said, okay, well, we want to turn over to this institutional owner exactly what was going to be built. And in order, when you think about it, on an assembly line for a car or a ship, the model truly reflects exactly what's going on. And it was a neat concept when you start to think about how much money, when you go back into a retrofit, we spend on verifying as-builts or not believing in the as-builts. There's a lot of money, hidden costs that are wasted, and we were able to, with this methodology, the craftspeople had perfect information for exactly where everything was going to go, and it increased the quality of their ability to build, and changed the focus from solving problems to focusing on execution of installation. The other thing that we started to realize is, and sometimes construction we're a little slow to it, but we really started looking at pattern recognition. When you start to think about these models and what are repeatable elements. Here's a picture of, in this medical setup, we had integrated ceilings, and we're starting to see one of the issues that happens. We don't reuse the models because they're not accurate enough. But when we draw them perfectly and they're accurate enough, we're able to go back and mine that data out of that model, mine that pattern, and start to reuse it. This is an example of, as we saw here previously, the uni-strut and the ductwork, and you can see the matrix of the pieces going in. Everything came in prefabricated, and these units ended up going up in one day. So again, you can see what it looked like and what the model looked like, and we're now going into the next phase of the project and using those as baselines. And in certain cases, with casework, starting to mine the model and not just using single pieces, but trying to model the largest amount of elements that we possibly can. Interesting concept here when we start thinking about the supply chain. Here's an example of, again, the computer orders the X, Y, and Z coordinates in the model. And in construction today, these units, and you'll see them all over the construction, where they're pulling the coordinates directly out of the model and placing them in the field. So these are two electronic total stations. The mechanical contractor and the electrical contractor both had them. We laid out over 6,000 points on the floor prior to steel elevations going in, and these were the coordinates that helped locate exactly where parts and pieces are going to go. The one thing that is not always understood is that the variation starts to affect the speed with which pieces can go in, and starts to cause problems. So since math is perfect, and we take them out to the normal significant digits, we can increase the speed and quality of everything going in with our precision. So here's an example of, again, looking at a ceiling with coordinates, the pieces being laid out, and then we also we generate pre-printed labels with barcodes on them to measure the rate of change and inform everybody as to what's going to go there. Again, utilizing the data, not wasting. We have the data of what the coordinate's going to be. Instead of wasting time printing it or writing it out, the pre-printed label we're just utilizing that data as much as possible. The other thing that we can do with this, and we call it IQ Whopper, it's an installation qualification work in place report. You're seeing a coordinate here. A lot of times people talk about clash detections in BIM modelings. We do what we call reverse clashes, where we've gone out and shot a coordinate for something that was installed. You can see this point here, and we bring that back into the model, and we're able to measure the accuracy of how well the work matched the model. The other part too is you start to can put to this that if the piece isn't in, we talk about work in place a lot of times, but there's not a quality element to that. And with this, you get you get the quality element. We say the work is in, but we don't know if it's out of plumb or if it's in the right spot. In this particular case, you know exactly where those parts and pieces are. The piece right here for this, and we're able to speed construction. This is a wood ceiling that they were looking for as-built information for finished drywall. In this particular case, we shot this before the drywall was on, but knew exactly what the tolerance was. With that information, we were able to release this wood ceiling for fabrication a month and a half earlier than would have normally with normal as-built information. The other part that's important is really to get this information out to the field. How much can we use our models? And here we've got four different pictures of basically different uses of the model. This upper right-hand corner here we had gone in and done a laser scan of an existing building. There was significant cost with this, and turning this into a model. It was a recently built building. It was only about a year old, but nobody believed the as-builts in it, and so we had a laser scan and then generate it into a model. That was, for me, the point at which I said, well, if I draw my models correctly and I build to match the model, then I'm going to be saving all this money on going back and laser scanning. In this upper left hand is an interesting one, and it really fits in with especially design and structural, where we've got a three-dimensional model here, but we've also got two-dimensional PT cables. And we started doing our inspections ahead of time. They were done almost 2 weeks ahead, where we had these sleeve locations and brought the structural engineer in and used our iBoards to talk about locations and how close they were to the PT cables. At that point, a couple adjustments were made, but it wasn't, and then we went out and took the coordinates and installed these pieces. The great part about this is again, another creative way of using the model. When the structural engineer came to walk the deck the day before the pour, there were no issues. Not the mad scramble that often happens. Again, utilizing that model as a communication tool. Here again is just the, on our jobs, we like to have the model out in the field, again, to get as much use out of it as possible. It's a projector with a computer and a gang box. And then this is the integration of the model with pictures in the field. And what you're looking at here is we had shot coordinates on this on these sleeve locations. We'd had to faro scan for finding out where the PT cables were at, and then took a picture of it. And we were able to bring that, because we knew exactly where the coordinates were, we brought that raster image back into the model. You can see this is a picture of sinks and some sleeves, and we were able to utilize that data more effectively in a communication tool. As a communication tool, and verify that the sleeves were going to be in the right location, and communicate with both structural and architectural and mechanical. People always ask me, where do you start with this, or what is BIM to some people that are just getting are new to it. This is an example of a project, and start out easy. This is an overhead photo. I've been inserting raster images in drawings for years, but again, I think sometimes we think of model, but we're also talking about information and how do we utilize it. So this is an overhead photo of the site with a raster image brought in, scaled up, and overlaid with the site utilities. Again, communicating with everybody, roughly where things are at as a communication tool and a great talking point. So you're able to verify issues. Now there's a level of precision and accuracy. It's within a couple 3-4 feet, but for this particular case, this works out just fine. A lot of times we'll put this under glass, print it out at a 1:20 scale, and you can. It is one of the most invaluable tools that we end up having. Structural steel takeoff and coordination. This model here is a 10.5 acre site. This building is 300 by 300. The people talk about who owns the model. I like to think of our models as community models. The grid lines or coordinates really set where pieces are, and in this particular case, as structural engineers started out with the model, and as we were able to slide models in and out, and they become self-checking. You can also see in this particular case down here that this model is integrated with the civil. We always believe that it's important to put our models in real-world coordinates and real-world elevations, and really increases the quality of models, especially that interaction at building lines between different design and construction trades. Continuous precision and verifying. In this particular job, we put 2,310 pieces of steel up in 100 hours. Just steel about every 3 minutes and 21 seconds. In this, again, back to our coordinates and tying these electrons to the atoms, you can see basically a reflective target, and we continually monitor pieces as they go in, check them back versus the model electronically, and it's able, instead of having our QC after the fact, we're QCing as we're going, which again increases our quality and cuts down on rework. Construction Industry Institute had produced a study a couple of years ago with roughly $4 billion worth of work installed and several large contractors that they were working with, and they were able to document roughly 4% of construction costs as rework. And so we really are working at making that, cutting down on that 4% with our quality. This is a great story, I think, for both design and construction. And this is a structural engineer. I love the eye boards, and I kind of call them a mind's eye board. The part about it is, I always think when I go back to the two-dimensional drawings, we're all seeing something different, and we're trying to create it in our mind's eye as to what it looks like. And when we start to model, we're able to collaborate more and bring it up and come closer to creating an understanding between all of us as to what we're really looking at. And the engineer here, we had up in the upper left-hand corner, we had some serious congestion issues, and again, really difficult algorithm as to how to get all this material in, and we were able to, we had modeled it, identified it, came in and talked to the engineer, and he did his markups here. When we got to this portion of the deck where everybody thought they were going to have a problem, everybody followed the model and the parts and pieces went together. It's a pre-planning, it's a pre-training, as Philip Crosby talked about with his quality metrics. It's build it once. I always like to say, everybody wants to, I'd much prefer to model it once as opposed to building it 2 or 3 times. And when you think about it, a lot of these structures that we build, in some cases, are only built once. So there's the greatest risk that goes along with it. So that the idea of modeling it gives us the greatest chance of getting it right and getting the most out of our learning curve. The other part of that too, and as Beth was saying, you're going to get to the point where you start talking about talking to owners and how modeling is important to them. With an accurate model, when we match the model and what we turn over to our clients, they can reuse that information themselves for the next build going on. So what are the benefits of this? When you start to have the idea of modeling to this accuracy level, we're able to, and it really goes back to Eli Whitney in the 1800s, who was the one, we know he'd been at the cotton gin, but more so he was really the impetus for interchangeable parts. So it's a bit of a mind shift. And I always, when you think of studs and pipe and nails, yeah, they are interchangeable parts, but we're able to do what you hear a lot of times in the business as prefabrication, offsite in larger units. And so when we know where pieces are going to go, we're able to do that work offsite. The benefit in that particular case is there's a lot less manpower on the job site, so there ends up being less dilution of our management and our G-stays. Customer satisfaction increases. They feel a lot usually the speed with which we build, it's very exciting for them. Now these numbers reflect Seattle, thousands of dollars per man month. So for some of the people back on the East Coast, New York productivity levels, just because of the cost of work back there, it's not applicable. But it is the bigger part of this is the 186% improvement or the 352% improvement in productivity on manpower is drastic with being able to do this. The other thing too, and I was trying to look for something to compare this to. Man hours per square foot is an interesting metric because it goes across space and time. So in this particular job, this Redmond project, we compared it to one of the best, most well-built buildings ever, which is the Empire State Building, and so we, unfortunately, in the year since the Empire State Building, we were only able to increase or cut it down to 1.5 man hours per square foot, but it still was a striking increase in productivity. Quality is significantly better, less rework. There's a lot more pride that goes on. And it works. It also makes the morale on the job a lot better, and better. I think the communication between design and construction becomes a lot more collaborative. More agile to deal with unexpected changes from the client. This is also interesting. When your model matches exactly what's built out there, you're able to actually see inside the walls, cost changes more effectively, and know up front what you can and can't do, and run through different scenarios. And in this particular case, on some of these projects, CFE has commissioned a study a few years ago where they were trying to increase speed of building to 1,000 square feet per shift, and we've been able to achieve that, but we wouldn't have been able to achieve that without modeling. It's also just another example of increase of mechanical and electrical productivity. And one of the things we start to look at is how many passes do you have on construction. What I like to call it is single pass construction. It is for sprinklers, installers, for example, we're in hard lids. We're able to have them come in, know exactly where their heads are going to be, have them set them to, since everybody sets to an elevation rather than measuring off the floor. Basically they bring in, run their mains, their branches, their arm overs, put in the heads to elevation, and they're only coming back to do trim. That's the part where you really start to see see some amazing productivity increases. The other thing the benefit of this is the green side. We called it lead lean. On our last project, we had looked at what we called target zero. We really started to see that just moving material, when you're bringing parts and pieces to the site, 10 to 15% extra, that material is being moved into the building and then has to be moved back out. And these are significant numbers. So on our most recent project here, we decided this was one area that we really wanted to attack. It's easy to measure the weight of material that's coming to the site on this particular TI, and we cut this down to 2.9%. When we compare that, it was a 68% increase or decrease in waste. On the project previously, when we figured 200 pounds of waste in about an hour to either move that on and move it off, we're looking at almost $300,000 savings just in moving material on and off site. From a construction standpoint, most workers spend about 1/3 of their time moving material. So it's it's something that we feel that from both the green side, the labor side, it's a win-win. The next thing we want to move into, we talk a lot about modeling, but the forgotten part of this is information sometimes in the I and the BIM. So in 1977, I started looking at, in 1997, I started looking at barcodes, and it took several years, to about 2007, to have them start to be used on the job site. And it's moving at a very fast rate, and again, it's data. It starts to end up being data management, and hopefully after you've seen this, you'll go around and start to see more and more barcodes and how can you use this. But we use these a lot, a great deal. You can see here on the right-hand side, we've got a door schedule on a door. Came out of the architectural schedule, and then this room number 104, and we're able to track the doors going in. The other thing too is when you start to think from the design phase, how many things are tracked back, or that thread of that room number goes through your finish schedules and your mechanical and your electrical schedules. And what parts and pieces of information can you start to glean from that, and then using barcodes to quickly manage that data. So you see here we've got preloaded data, finish schedules, mechanical, medical equipment schedules, electrical equipment, and owner furnished, contractor install. Here's an example. These are the barcode readers that we use. Either today we will even use some of them on our phones. This is an MC9090 that we've used in the past, same sort of thing that you'd see at any large department store or grocery store. And a bit of a list here of what we're tracking: door frames, door leaves, MEP equipment, security, safety equipment, punch list. Up in the upper right-hand corner here, this was we had this for, it could be either for punch list, or it could be for out of tolerance pieces, and we had pre-printed tags. We scan them quickly, put in the zone, the quadrant, the floor, assign it to a contractor, and then this data all went up into a database. We've also used RFID tags on several projects. Work great for hidden equipment or for a lot of underfloor equipment. And you can see we've started moving to QR codes for a lot of the work that we're doing, just because it can hold more data. Just a quick look at the interface and how these parts and pieces work. We talked a lot about assembly lines, and we talked about buildings being an assembly line, but when you start to think about it, data is an assembly line also. And here is just an example of what we kind of mapped out for information. So if you imagine a light, that light, the information for it is used in the design, the estimate, the master planning, the purchase, work breakdown structure, submittals, detailing, a lot of times the second work breakdown structure, last planner, fabrication, shipping, receiving, installation qualification, inspection, startup, commissioning, punch list, owner training, and maintenance. And for us, we started to see that we really believe that information gets lost a lot of times. But now with the ability of the technology, we're kind of shuffling that assembly line of data and making more effective handoffs, and realizing that we all use that data in different ways, but the information in BIM is, how's that end up being used? And this is a great one, again, with that maintenance department, is turning that information over to our clients as end users. In the lean part of that, we're really feeling like we're creating value by cutting out the waste, figuring out what's appropriate, multiplying that times our outcome and our service, and realizing that sometimes we're not just producing a product here, but we're really more of a service organization, and serving our clients and our customers and our partners, and that you're creating there's an experience which in the end creates an object, but it's a process that we're working through. Fitting into that, and really dovetails well into to BIM and this building information modeling, is a lean approach to that. Creating this framework, you can see that as I've been talking, we try to get as much out of that information, but we're all using that information sometimes in different ways, but it's the same information, and it allows us to collaborate a great deal more and make much more effective decisions. When you think about a building, and I think sometimes we forget this, but we all come together in the building itself, and what modeling allows us to do is to put that to come together in the model ahead of the building, while it's still kind of an electronic form, and that way, as you're working through that process, the cost of changes or mistakes are a lot less. The other thing is that this web of reliance, it makes it much more transparent, and really does cut down, it increases the quality by cutting down on errors, because there's just more people seeing it. The other part of this, and I really might have to change the slide just a little bit, but when we think about the tradesperson and the lean part of this, but really at the very top of this is our client, is our customer, who we're talking to, and we take, instead of this top-down approach, we take much more of a service approach to this, and that by thinking about the perfection at the connection, and that tradesperson, you could actually talk about perfection at the use point, where we started this with the mock-ups, is that this informed design from what our client is going to, how they're going to use the space, and how it will accentuate their feelings and their ability to perform whatever function they're going to do, becomes much more, is front and center of exactly what the entire team is looking for. With that, when we're able to do this and have a lot of those touch points, we find that our clients come in at the end, and instead of saying, why did you do it like this, they're like, this is exactly how I imagined this space. So with this integrated approach, we applied this lean production system in this process. You tie in the building information modeling, and it helps accentuate that integrated project delivery in that environment. And bringing all those two together, it becomes it's much more successful. These last few slides are just some examples of the outcomes. We bring these models, again, we talk more about this use of this visual workplace and bringing the models out to the field. These are head walls in a hospital, and the prefabrication that's allowed with that. Using it, again, prefabrication, or we like to call it external setup, is externalizing the work, getting it off-site, and then having the parts and pieces coming in and just fitting together. You can see here, again, this is a great example of what we really see the future as being. Visual workplace of lean. Every contractor has a color and when they're finished and the wall's ready to be covered, they paint that color on there so everybody knows what's going on. You can see over here, this is the elevation of that of this wall. So when the workers come out, they not only have the drawings, but they've got a picture of exactly what this is going to look like to check and to preset themselves up. And then again, a label of what room this is, which wall it's going to be, and in this particular case, we have a photo of it. We take photos of all walls prior to closure, and it helps us keep them clearly organized. The other part of this, again, we talked about an assembly line approach. You can see here we set our projects up as an assembly line and a swim lane lean approach. And back to the consign model of as design goes, we're able to deal with more discrete areas, giving design more time. This was a neat project where part of the design, the owner hadn't made all their decisions, so instead of clouding what the change was going to be, we actually went the opposite direction and put a cloud in as to what wasn't designed, and we're able to work at all the other spaces and keep the project on schedule. Just an example of an assembly line approach. It also keeps the jobs extremely clean, organized. With these discrete pieces, again, we talked about an assembly line. We assemble the supply chain. The data out of submittals gets loaded directly into a supply chain management piece. That visible supply chain gets tracked as units and pieces come from fabrication come across the country. Pictures of every pieces or objects are taken, and those become cards to notify that work's ready to go in. And then we manage a flow center to speed up the work and get truly just-in-time information and communicate that to the field that parts and pieces are ready to install and then move on to the next location. The benefits of this is the other thing that's a benefit of this is what we call situational awareness. You know, we think when we get on a football field, everybody knows where they're going to be, even though there's a lot of chaos. We've asked the question, you know, if your first day of productivity is less than your second day, you know, what's causing that? If we're in an assembly line, it wouldn't be there, but in a building, a lot of times people don't know where they're at. They have to get familiar with what they're at. The model also builds to that, where people are pre-prepared for where they're going to be, what they're going to do, and we're able to increase our productivity from that. We're also taking this data and using process flowcharts, and again, we talked a little bit about distance in feet, quantity, time, eliminate, and with this pattern recognition that we're utilizing, we're seeing every job as the same now with a little bit of variation as opposed to every job being different. And we see the future of us as we gather more knowledge and apply this pattern recognition to it, to building faster with higher quality. And the quality is front and foremost in that's what, again, this elimination of waste, this example right here, what doesn't need to, what is the waste, what doesn't need to be done. Again, planning that productivity, utilizing the information, and doing pull plans. This is a pull plan for work, but we also do this with our design team to make sure that we truly understand you know, what's the most appropriate information to have, and how do we get that in the right order. The other part of the BIM processing, we talked about cutting down on the waste. You can see, again, the data comes out here is what exactly pieces are going to be here. On that last job, 95% of the studs came out pre-cut. They cut down on the noise. Also made sure that everything was aligned. Increased quality, which increased speed. And then we talked about moving at 1,000 square feet per day. In this particular case, the prefabrication of these steel units, we were able to build at 1,000 square feet per hour. The results, you can see these are weeks to weeks project. When everything's pre-planned, everybody knows where they're moving. We're working at single shifts. Prefabricated exterior panels, rain screen. A Class A office building in 44 weeks. And with that, that ends my portion of this. Thank you very much.
Thank you. Excuse me. Thank you, Chris. That was really excellent. And our firm at ZGF worked with Turner on the last project, and it was interesting to see just how fast things could go together and how much improvement in quality this kind of process had. So it's been really great seeing that flow through. And we didn't have any questions that came in. We had one comment about terminology of man-hour and man-month versus crew effort, to just this terminology of today. So, but with that, it's been really excellent hearing from you, and I hope everyone had a great presentation. Is there anything else you want to add, Roger?
No, I mean, it was spellbinding. I think that's why there weren't any questions. You did a great job, Chris, and really gave us a lot of information, and I think impressed at least me with this sort of view of everything that you can do, and it's interesting how it just keeps building on itself. I think once you start to collect one bit of information, you keep adding to it, and then you get more value out of it. So I think that was an interesting observation from this.
Yeah, thank you, Roger. Yeah, it is amazing. I mean, I'm currently collaborating with ZGF right now on another project, and we're fully Revit based, and it's what I'm doing, but it's also what ZGF's doing, and how we're able to feed off of each other, to using different information, and making this visual workspace even better. We're starting to embed pictures in the design portion of it. I really look at the next 5 years in construction as to be a real. It's going to be really exciting. It's the first time that I've seen sometimes the software and the computers didn't, they would get bogged down. It's just, there's so many exciting things going on, and it's moving at a really rapid pace. But I see some pretty amazing things. We still have a long ways to go, and some great opportunities where I don't think we've even imagined what is possible. So.
Yeah, and Chris, we got one question that says, are you using this process on all building types? And I know for sure that it's healthcare and office. Are you using that on all of them?
Yeah, we are to different levels. The one thing with the healthcare, we are all client driven, and what's our client want to have. So healthcare is really vested in it. And we're starting to move that out. The Redmond project was interesting, where the client begrudgingly let us use BIM, but didn't think it was worthwhile. By the end of or about halfway through the project, they were true believers, and now give speeches with their lawyer recommending that everybody should be doing BIM to this level. So, you know, it's a process. There's a lot of people in the business who've gone, well, yeah, that's great for this, but I'm a different outfit. It's moving quickly, I guess I should say. So I would say in the next few years, especially for most clients, and I think most institutions will be doing this. This is definitely the way to go.
Alrighty. Well, with that great comment, talk to you later. Thank you much.
Bye-bye.
Thanks. Same here. Bye.